Okay, back for our second video for this lab. We can see that we have our player movement that we had been creating here. Now, I want the camera to start following me. Now, we could have the camera just follow the player directly. It gets a little bit hard to see the world constantly moving back and forth. And so what we've defined here and what you can see is there's sort of a boundary. When I bump up against the boundary, the camera starts to move. But if I'm in the middle of the world moving back and forth, the camera doesn't need to move so much. It only needs to shift when I'm almost ready to go off the screen. So let's see what we can do to make that happen. And what we're going to do is use sort of a FollowCam idea. There's many places out there that do this. One way that you can find as a reference is the Introduction to Game Design, Prototyping and Development book. Here, I think it started off in Mission Demolition, Prototype 2 that they go through. And so I'll use some code from there and start remodifying it into our code for this project. Okay, so it's going to be easy for us to detect bugs if I start to make the game its own sort of panel here. And Unity lets you be really flexible if you're like, I want to see what's happening. And so you can see that the shape of this camera is the shape of this window. That's a little disconcerting. It has free aspect. Well, you can pick whatever shape you want. I'm going to pick 600 by 600 just because I'm doing stuff with pixels in this game. I want it to be a nice square, but I could make it so it's 960 by 600. Whatever I want to be my frame is the frame that I start to see over here for my camera. Okay, so let's get working on this. I want to start doing stuff with my camera, and in doing so, I need to go back to my project and write another script, which is going to be following the camera. So if we attach this follow camera script to the camera, then as we do stuff, it's going to be making the camera move its frame of reference around the world. Now, let's play the game just so you can see in these two different panels here. This is what it's going to look like on the screen. And then we can see that I'm moving out of the range. I'm still there, but I've moved out of range of the camera. What I want to do is create this buffer, this boundary area around the camera that if I ever bump into that, the camera is going to move and try to follow me. It's going to follow the player. Okay, let's go write our script. First thing we want to do in FollowCam is we need to know who we're supposed to follow. So let's give ourselves a game object up here. Public game object player. And before I forget, because I commonly do, I look at the camera here and I would say, hey, look, I have a player. Let's drag my Groundhog over to the player spot. Now I'm going to have a player that I can follow and talk to. Good. So back here, let's define something for the boundary. And we're going to let the user change this if they want to. So we're going to make it public boundary %. Yeah, just so I don't fool myself, I'm not going to assign it to a number here. I am going to let the user be in charge of that so I'm not tempted to come back here and change it from 10 to 20%. So let's go set things up. I need to have some numbers. So this % is good, but it depends. I want to actually have it in pixel numbers to make my math easier later. And so I'm going to have, say, a private float left bound. And I'm going to do it for just the left and the right now to make it more straightforward for coding, and then I'll quickly add in the other pieces. So what is my number of pixels on each side? I need to calculate it. And I just want to do this once. I don't want to do it every single update. If you can do stuff once in a game, you can increase your efficiency rather than doing it 60 times a second. So if you're calculating something that never changes, always try to think how I can make that into a constant, make it into something that I calculate once, push things out of that update loop as much as you can. So I'm going to say boundary percent here times camera, which is a nice global, and main is the thing that is tagged as the main camera, times pixel width. And then the right bound is going to be equal to camera main pixel width minus the left bound. So if my pixel width, which is defined here as 600, times, say, 10%, then this is going to be 60. And then I'm going to say 600 minus 60 gives me 540. So I have numbers in terms of the camera pixels where my boundary is. And those are not going to change throughout the game. If they are, well, then you go change them. But this lets you do it once and just use these numbers now based on the camera that you are given. Okay, so now I want to do an update. And I'm going to make this a fixed update again. This is going to be my fixed update here. I'm going to say, well, what if I forgot things? If I forgot to set up my player, then don't worry about it. But if I do have a player, then I need to figure out where it is. Now we're tempted to do vector 2, and I messed this up in class, but we want to do vector 3 like I had thought. I thought I could get away with a shortcut of vector 2, but in doing vector 2, the z coordinate is always 0, and the overlap was not happy with where it needed to be. So let's make a new vector 3, which is, where is this sprite? Now we know where the sprite is, right? And it's player, transform, position. But this is in game space. This is in coordinates of this world, not in coordinates of the camera. And if I'm caring about coordinates in the camera for my boundaries, then I need to translate this based on the camera, pass it through the world to screen point function. And so it says, take things from the game world and turn them into pixel numbers. And so now I'm going to have my sprite location in pixels. This is good. Okay. Let's go get the transform of the camera. And if we have the transform of the camera, now we can say, hey, sprite location, the X that you have, if you are less than the left-hand bound, then I need to fix things up. I need to change the position of the camera's X to subtract off the lower bound minus the sprite loc X. Okay, I need to do the same thing for the right-hand side. If my sprite loc X is greater than my right-hand bound, so if I got greater than 540, then I need to fix that up. And I need to say my X coordinate of the camera needs to move and get bigger to sprite loc X minus the right-hand bound. Okay, keep shifting myself over, and now the camera is in a new spot. Almost. We have one more thing we have to do down here. We have to put the transform position of the camera back as that position. I can't really change. I can't say transform.x equals something. I have to go get it, change it, and then put it back inside that transform. I'm not allowed to set it. Okay, so let's see if this works. Well, it's only going to work going left to right. So those are going to be the ones I test here. See, I can move back and forth. Oh, I got close to the edge, or I hit the edge. Well, that's because I didn't change things. I don't actually have a percent. If I look at my camera over here, my boundary percent is 0. If I do 10%, as I was talking through in the example, then if I play it, notice that when I get close to the border, boom, it starts to move. Hooray! But that does not look good. It is very jittery. In the next video, I'll talk about the easing, and I'll put in the up and down frame of reference so that we can make this a bit smoother. There's a great way to do smoothing as we are moving things, and we'll talk about that in the next video.